welcome to the TechGeek webinar on best practices for AI/ML model development, deployment, and usage. I'm your host, Sukriti. Thank you so much for joining the session today. Now, AI/ML models are being extensively used in the financial industry for purposes ranging from customer sourcing, credit scoring, campaign management, fraud risk management, anti-money laundering, rewards management, risk management, and operations. Usage of ML models have made it possible to do tasks which otherwise have been very cumbersome or humanly impossible. For example, in fraud risk management, ML models can identify patterns of suspicious transactions from huge volumes of transactional data, which otherwise would not be evident applying casual observations technique. However, there's a flip side to the usage of ML models as well. Machine learning based models could suffer from serious flaws such as instability, bias, and explainability if the models are not constructed, used, and governed properly. Now, during the webinar, our guest speaker will cover key best practices which could reduce such risks across the life cycle of a model, which is development, deployment, and usage. Folks, please join me in welcoming our guest speaker for today's webinar, Mr. Kasturi Rangan Bhaskar, who is the Vice President Products at BCT Digital. He is a product leader and banking finance subject matter expert with a proven track record of orchestrating fintech products to success from 0 to 1. He currently leads the products at BCT Digital. He has 18 plus years of diverse techno-functional exposure spread across roles in commercial banking, lending, digital transformation, risk management, technology, pre-sales, and B2B product management. He's a qualified CA and an associate member of CPA and holds an MBA as well. Now, without any further ado, I will hand over the session to Kasturi to take it forward. Over to you, Kasturi.
Thank you, Sukriti. Good afternoon or good evening, all, depending on from wherever you're joining. So today's topic for discussion would be best practices for AI/ML model during its life cycle of development, deployment, and usage. And of course, that's a brief profile of mine. Sukriti has given a very generous introduction. You can find me at the following, a LinkedIn profile, which has been given on the screen. I've been extensively working in the areas of lending, credit risk, GRC, model risk management, for the last 10 years or so. Before that, I was a commercial banker. So I've seen both sides of the from both perspectives, being a banker, commercial banker, and being a technocrat as well. So I have kind of witnessed the space from both the lenses. So that's just a brief introduction of mine. So without further ado, we'll directly jump onto the topic. So in today's session, I hope to cover these agenda items. We'll start with a basic introduction on where all AI is being used, the key functional and technical challenges around it. Then we'll move on to what is there from an Indian context. What are the challenges specifically from an Indian context? Then we'll dwell a bit deeper into the regulatory concerns of bias and explainability of models, what it is all about, and how do we kind of mitigate them. Of course, this is a very vast topic by itself, but I'll at least try to highlight some of the key areas of concern. Then, most importantly, the core topic of today's discussion, which is the model lifecycle, AI model lifecycle, which means we'll have to go through the lifecycle of a model as it is, which is starting from development, deployment, and usage. So we'll go through the steps and we'll discuss about what are the best practices that can be sort of rolled out at each and every stage. Then the three pillars of AI models product management, which is governance, validation, and challenger models. We'll also see what it entails. Then I'll give you some references, some very interesting references that you can go through at leisure. Then towards the end, we will have a small application walkthrough with the help of screenshots. Just to probably bring about how it is actually done in a real life scenario. So that would be the agenda for today. So AI models, I mean, they are kind of becoming all pervasive. I mean, they are a kind of sneaking into each and every function of banking and fintech related areas. They are increasingly replacing human judgment and effort. Why? We'll see it in a bit. But some of the areas where AI models are being increasingly used are lead generation. We'll look at some of the key areas. Lead generation is one of the area. We'll just go through it in a logical sequence. For example, for personalized marketing, I mean, who should be offered what? Whether if you're an affluent customer, then you should be offered one kind of product. If you are a kind of a gig worker, then you should be kind of another kind of product. So how do you decide that AI is being used? Then tracking customers' buying preference over a time. Is a customer kind of going in for very high valued premium kind of products, or is he going in for unsecured loans, which could signify certain things? So tracking such customer behavior. Then prioritizing lead for sales channel, because I mean, what could potentially happen is the campaigns could be kind of delivered through various channels. Now, how do you decide which of the lead you should address? How do you kind of prioritize that so that it results in maximum conversion? So that is being decided by AI these days. And of course, they're running the entire campaign by itself. So how do you decide which is the most effective campaign technique for a particular individual? For example, let's say you're targeting a unsecured loan for a gig worker or someone in a semi-urban area. Then email campaign might not be the most effective one. So how do you define the dynamics? So keeping in mind the cost factor, how do you define which is the most effective campaign management for a particular individual? The AI is being used there. Then how do you improve wallet share for a particular customer through cross-selling or upselling, or for that matter, suggesting certain optimal investment strategies in the case of wealth management? AI is being used there. And of course, for credit scoring, we all know AI is being used in various aspects, right from, let's say, for example, for BNPL cases, credit decisioning is being run through AI. Then identifying repayment patterns. So what has been his repayment patterns are, and are there any early warning signs of his kind of being delinquent in the near future? AI is being used there. Then collating and sort of data from traditional data sources, non-traditional data sources such as social media, and how do you kind of incorporate it into a score? AI is being used there. Then in KYC, again, your image recognition, OCR for digitalization of manually filled forms. In all these cases, AI is being used there. Then in the domain of risk management, predictive analytics for identifying risk of default, suggesting risk management strategies for such as hedging. So how do you hedge a particular position? Again, AI is being used there. Then for identifying suspicious transactions or AML cases, AI is again being used there. Then AI is also percolated down to the customer servicing part, where they are being used for chatbots, contextual emails, voice-based responses, and so on and so forth. Then lastly, in the back office part, operations part, AI is being used for repeatedly automating tasks such as form filling, data entry, automating workflows, MIS, and so on and so forth. So in short, AI is being used at multiple places. Various use cases have cropped up in the recent past, and which is a good thing. But it has its own flip side as well. What is the flip side that we'll see in a bit? So what are the reasons? Why has this AI models becoming all pervasive in nature, to the extent that it is kind of replacing the human effort or human judgment? Some of the key reasons could be high volume velocity of transactions or data being handled. So what is not physically possible by a human effort, AI is sort of helping us out in kind of processing the transactions or data for that matter. Then there is always a limitation of identifying patterns through the usual cognition method. Like just by observation, you cannot uh, identify certain patterns. It's very difficult to identify certain patterns. AI helps in that aspect. So that's another reason why AI is being, adopted. The adoption of AI has been on an increase. Then, of course, there has been too much information overload. There has been data from different sources. So how do you collate those data? How do you make sense out of it? There, human beyond the human cognition, AI is AI is helping us in kind of making sense out of it. Then, of course, frauds and AML incidents are on rise due to various aspects, mainly because of the ease of conducting digital transactions. Again, AI models are being used for routinely for improving the efficiency or efficacy of such models. Then, of course, there is a need to automate certain routine activities, and AI is kind of being used to reduce the cost and time, bring about cost and time efficiency, and thereby boosting productivity. So there, AI is being of a tremendous value. And all this is happening because there is an increasing digital reach. Because if you look at the life cycle of, let's say, app-based transaction, or let's say UPI-based transaction, there is very minimal human effort involved, other than at the time of initiating the transaction. So the entire life cycle happens in a digital way. So you need an equally powerful capability to kind of monitor, scrutinize, process such transactions. Then nothing would have been possible had it been for the had it not been for the decrease in compute power, which means your hardware, your memory and processing capacity has increased tremendously. The cost of hardware has tremendously come down. The processing capacity has tremendously increased. You might have the best AI model, but if you don't have the backing in terms of the processing power, hardware, and so on and so forth, AI would not have been so successful. So that's another reason for adoption of AI. And of course, lastly, ease of deployment. Nowadays, you don't need to be a data scientist to kind of roll out a machine learning model or an AI model. You can just log into a AWS platform. There are a number of models out there for various purposes, right from image recognition to voice recognition, your chatbots and all those things. You just plug into it and you can start using it. So it's quite easy it has become quite easy to deploy AI models these days, and which is another challenge that we are going to talk about. How do you manage these things? But in short, these are some of the reasons why there has been a tremendous increase in AI in the last 4-5 years or so. But things are not as rosy as it seems, because the devil always lies in the detail. Because if you look at it, AI is not a standalone entity. It does not stand on its own legs, actually. There are way too many dependencies. The dependencies could be in the form of infrastructure, your hardware, processing power, connectivity, and so on and so forth. The algorithm based on which the AI runs, the modeler's expertise is a very important factor. Then, of course, the quality of code and the quality of data. These are very important factors in the success of an AI model. Then, of course, your product configurations, because there's a lot of dependency on your product configurations in terms of its thresholds, logical operators, etc., etc. They do influence your AI models at some point of time. Then lastly, the regulatory compliance. So how far are you compliant with the regulatory guidelines? Meaning you have to operate within the regulatory framework. So there are a lot of dependencies for AI model, and as I said, it does not stand as a independent entity on its own. Therefore, we need to properly manage AI models at each and every stage throughout its life cycle. So it's like the proverbial tip of the iceberg kind of thing, where what you see is not what is actually the problem that you deal with. What is not apparent is the problems that you have to deal with. So there is a big iceberg sitting out there, that bottom part of the iceberg sitting out there, which has to be very carefully managed. Otherwise, the benefits which we hope to get by use of AI models, they might kind of overshadow they might be overshadowed by the kind of pitfalls that we are going to face through the mismanagement of AI models. Yeah. So let's just go through this through a case study. This is just a hypothetical case study where, let's say, there is a company called XYZ, which disperses loans to customers, unsecured loans to customers, particularly for the lower mid-income group. Let's say for the they are not for the salaried person, but for people who earn temporary kind of income, for the gig workers and those kind of things. They use it in the areas of origination, credit scoring, fraud risk, and so on and so forth. So this is the company that we are going to talk about. And this gentleman, Mr. Ravi, he's the chief data scientist. Now he's facing with a very peculiar problem, in the sense that there have been stretched payments or defaults by customers who have been flagged as good by the AA models. Then lead conversions have been taking place in the recent past. Despite extensive social media campaigns, they have been running campaigns, but it has not been so successful in terms of getting the right conversion. A lot of frauds have taken place despite having those so-called AI models. Then customer issues in the form of improper response by chatbots and those kind of things. And auditors raising concerns on the transparency and the efficacy of the models. So these are some of the models which the company's chief data scientist is facing. So following which, what he decided to do was he appointed a third-party consultant to investigate into the matter. So that's the simplest thing, at least he can do, to get an outside-in view of the whole thing, what is happening and what to do with it. So the consultant did a thorough analysis of the AI models and presented to the senior management a list of findings. So what are the findings? We'll go through in the next few slides. So this is the case study that we are going to talk about. Okay. So broadly, if you look at it, AI models, the challenges posed by AI models can be classified into the functional part and the technical part. So for ease of understanding, we'll break it down into two parts to it. And this is exactly what the consultant had also presented. I'm just presenting it in a slightly different manner. So what is happening is, for the AI models which have been running, which XYZ has been running across its different functions, the models which have been developed have been kind of trained or developed using very carefully cleaned models, which have happened in a very sanitized kind of environment. But in a real life scenario, the kind of the data which the model is facing has been completely different. So in the sense that XYZ's model was kind of operating on trained data, which they got from a anonymized data, which they got from a third-party vendor, which was kind of curated data, and this was not representative of the real life situation which the company was going through. So what is the implication? The implication is unstable models, out of sync models. They are not in sync with the reality. Probably the models might have been developed using data curated from affluent customers, from let's say metros, but their target segment is tier 2 cities or villages or non-urban centers and those kind of things. So the model is not able to sync up with the population that it is going to serve. So this is one major problem the consultant identified. The second major problem is explainability. What does explainability mean? We'll go through it. We'll go through this aspect in slightly more detail. But uh, I mean, in simple terms, explainability means that you are able to observe the output, but you are not able to correlate why that output has come and what is the relation between the input and the output. You are not able to draw any inferences between input and output. So this is the peculiar challenge which XYZ was facing. Therefore, let's say if income levels have got modified during a period of time, because it can so happen that in a country like ours, income levels keep on changing as a country moves through various phases of economic transition. The income levels keep on changing. So how does the feedback loop working? So how are you taking into account the increased income levels in your model? That's not becoming very apparent. So that is what we mean by explainability, meaning there is no relation between the input and output. You're not able to explain the relationship between the input and the output factors. The third aspect is what is called as cake, which means changing anything changes everything. So the model itself is so intertwined that even if you change a small thing, even if you change a small output, it has a big ramification on the output. For example, in XYZ cases, they were using close to 15 variables, including some of the non-traditional data such as smartphone usage and those kind of things. So by dropping or altering even one variable, it had a huge variation on the model itself, on the outcome of the model itself. So this is what is called as changing anything changes everything, meaning the implication is not linear. So had it been a linear model, we could have probably adjusted by changing the weights and so on and so forth. But in an AI model, if you change one of the inputs, it might have a more than disproportionate kind of impact on the output itself. Then there were undeclared customers. And there were undeclared customers, meaning some of the output of the AI models was being used by uh, uh, operations, by some of the business operations, for which it was not intended. For example, the scoring model was being used by let's say a lead generation vertical or lead generation business services, meaning the output from the unintended customer silently crept into the entire model itself. Actually, some way the model was getting impacted due to that. So that's what we mean by undetected customers, meaning the model was not meant for a particular purpose, but what was happening is, because it was being used by a particular business for a business objective, the impact of that particular business objective slowly crept into the model itself. Probably the model got retrained, which was not intended. So, which means that it could negatively influence the model's behavior. There could be false positives and so on and so forth. So primarily, these are some of the technical challenges which XYZ was facing, kind of grappling with. There could be other technical challenges as well in terms of, there could be other technical challenges which XYZ was facing in terms of data management, managing the data gaps, quality, governance, and privacy, and so on and so forth. Then there are issues relating to near real-time computation in terms of the near real-time computations getting impacted due to the latency in infrastructure, because your infrastructure is always not up to the mark in a real life scenario, particularly for near real-time conditions. There is always a lag. So how does it impact the AI models? Then processing and queuing of data, large data. Specifically, let's say if you're operating a transaction monitoring system, so how do you queue large amounts of data, and how does it impact the performance of the models? Are you able to queue it and kind of process data seamlessly? That's a technical challenge which I mean, in any company like XYZ would face. Then you also have this, case of frequent updation of scenarios, meaning, let's say, fraud risk scenarios. Now you have a fraud risk scenario coming up every other day. There are different kinds of scenarios being perpetrated by the fraud actors, and you need to keep on updating. So how do you do that? How do you maintain the models in light of the frequently changing scenarios? So that's a very challenging task. Then third thing is, there are multiple deployment approaches that needs to be followed. Like for example, some of the models need to be deployed on cloud, some of the models need to be deployed on as a web service or locally, depending on the specific need. So within a company or within an environment itself, you need to do multiple approaches for deployment. So how do you manage all these things? That's a very big challenge. And of course, lastly, version control, because you might be having different models. Each model will be going through a different kind of life cycle. They may be having, you might have one version for one particular geography, another version for another particular geography. So how do you collate all these and make sense? That's a very challenging thing to do. So these are some of the challenges which AI model poses. So that's what I said. Managing the bottom part of the iceberg is the most challenging thing, rather than what is visible, what you just see. And as I said, AI models are not a standalone entity. There is much more than what it meets the eye. So coming from an Indian context, what are the key challenges? I'll just take. I'll just discuss two of them. One is, which I kind of already hinted, the data is not representative of sample in many cases, particularly as time goes by. For example, we have a very fast changing demographics in terms of your population, age, their income levels, their education, and so on and so forth. So as the country goes through a transition phase, the models which you might have developed probably, let's say, 5 years earlier, they might not hold good for the current income levels, because things have changed actually. So you need to constantly revisit the models regularly revisit the models, and ensure that the models are in tune with the population that you're trying to address. And second unique thing is, there is very little industry level coordination. To ensure that appropriate benchmarks are set. For example, you cannot benchmark your model against an industry model and say that mine is at least at par with the industry. There is no shared repository as such. Unless someone shares such data in a public or a private forum, there is nothing to benchmark. So how would you know your model is performing better or not? That's a big challenge. Likewise, even from the data perspective, there are certain there are certain segments of data for which only certain users are privy to. For example, default data, fraud data, or maybe only banks or NBFCs, your regulated entities might come to know. Other people might not come to know of such details. So there is lack of industry level standardization or shared repositories, which could have been very useful for improving the quality of models. And lastly, of course, there is no regulatory push as such to maintain model standards. For example, if you take the case of Europe or US, there are definite standards which say that models have to be maintained as per certain standards. Now, there is no incentive as such from the regulatory side for the companies to maintain certain model standards. So, I mean, it's like more like a chalta hai kind of attitude, which most of the entities adopt, and they're somehow kind of managing it. Now, quickly going into the concept of explainability, this has been highlighted as one of the key concerns, of regulators across the world. Specifically, RBI has also talked about it in various forums. See, explainability, as I said, it is how do you kind of explain the output and the input? So what happens in between that? That is what is the main core of explainability. And we can look at explainability through various angles. There is no one single version of what explainability means. So, for example, if a model developer or a data scientist looks at it, he will always look at explainability from the perspective of a trade-off between accuracy and explainability. So he might going in for better accuracy, but compromising on explainability. So for him, explainability means slightly different things. But if you look at it, from a perspective of a risk manager, he will look at it from the point of view of how will the model break down, or when will the model break down in terms of the stress scenarios, under what conditions the assumptions will not hold good. For him, that is the explainability point of view. For a bank employee, it could mean, is he able to explain or for a fintech, for a business person, it could mean whether he's able to explain the use case or the model to his senior management, how well he's able to explain that. So explainability takes different shades, and it is not constant in nature. And if you look at it from a perspective of a regulator, it means that, are you compliant with certain regulations, certain customer protection rules, and so on and so forth. And lastly, for a bank customer, explainability means, do I understand the scoring approach? Will I be able to improve my score based on certain conditions? For example, if I make proper repayments on time, would it automatically translate into better scores? That's what explainability means to a bank customers. So in short, explainability does not have one version. There is no single version of truth. It means different things to different people. Therefore, explainability can be kind of understood in terms of bringing about transparency, ease of understanding for different stakeholders. Let's say, how do you explain it to an auditor? How do you explain it to your own senior management, for the different stakeholders, for your investors? So how do you maintain the transparency? That's one important component of explainability. Secondly, traceability of different components, for example, the model parameters, thresholds, and so on and so forth. And the ability to question back, saying that why it is so, and what if, why it is so means, why has this output come? And what if means, what if I were to change my input, what would be the impact of such a change on the output? So the ability to question back that model should be very clear. And some of the approaches how you can improve the explainability would include not making the model complicated more than what is required. There is always a trade-off between accuracy and explainability, and the trade-off should always be maintained, considering the interests of various stakeholders. And there are various techniques to improve the improve the explainability part. Like, how do you explain the individual components through, let's say, techniques such as your expectations plot, and so on and so forth. And how do you explain the impact of the components put together? So individually explaining it is one thing, and how do you explain the collective impact is another thing. So there are various techniques which are beyond the scope of this discussion. So how do you do this is one important aspect of explainability. Then we'll go on to the bias part. So bias simply means a segment is being unfairly left out from whatever is the intention of the model. A segment is being unfairly left out. For example, in case of a credit decisioning model, it could mean that a certain segment of the population is being left out uh, 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 unfairly unfairly. Uh, as I said, many of the regulators have commented on it, and there are also laws against this. For example, in the US, we have the Equal Credit Opportunity Act, which prohibits any such bias against a particular segment based on race, color, religion, etc., etc. So some of the sources of bias in a model could be the training data itself. You could have chosen the data which could have been heavily skewed against a particular segment. The algorithm could have triggered such a bias. For example, double counting or overweighting certain factors could have triggered such an algorithm, such a bias. And of course, the interpretation part. So how do you interpret it? What is called as the interpreter's bias. You are the way a particular person looks at the output of a model could have been biased by his past experience or judgment. So there are these are some of the important sources of bias, and to remove that, human oversight over the models is a must. Whatever models it may be, periodical human oversight in the models is must to reduce the bias. And it's very complex because understanding and removing bias not only involves understanding of data and data science, but also social science. You also know how does it impact the customer segment that is serving. Does it leave out a certain section of population? That involves a little bit of understanding of social science aspects as well. For example, these are some of the real life scenarios where models have been found to be biased. For example, in case of US, fintech institutions have been found to be running models which are found to be discriminating based on color. And there are other examples as well. You can go through. It's there on the internet, and you can go through that at leisure. One interesting case is in Australia, ChatGPT invented hypothetical cases which were presented to the court. The legal cases doesn't in fact exist at all actually. Because of some kind of bias that went into the model. So these are quite quite interesting cases that one can read about. Now, we have talked about the problem. Now, what needs to be done actually? See, there is no one single aspect that if you do this, things will be in order. There is nothing like that, at least when it comes to AI models. Now, we need to understand what is called as AI models product, your life cycle in entirety. Why? Because they have a domino effect. If you do something wrong initially, it has a cascading effect all the way till the end stage, and your output, the intention of the model would not be. You would not get the real intention of the model. So broadly, we can classify model development into 2-3 stages. The first stage is the development stage, which includes the ideation part, where you ideate what model you should build and what factors you should consider. It's a kind of rough sketch that you do, whiteboarding and all those things. Then you actually get down to the design and development part, where you work on a couple of models, your approaches, you work on data, and so on and so forth. Then comes the testing part, where you do various kinds of testing. There could be pilot testing, sandbox testing, UAT, depending on the particular use case that you are looking at. And you have the validation part. Validation could be either internally or externally, but needs to be independent of the person who has developed the model. So broadly, these steps are called as the development stage. Once we complete the development, it goes for deployment, where the models get deployed on the production environment. Then once it is deployed, you need to validate it using various techniques, what is called as continuous validation program, calibrate it for any changes. And of course, you have the concept of challenger models, of which we'll talk about it shortly. Towards the end, you have the model retirement. When you feel that model has served its life, when you feel that it has to be retired, eventually it has to be phased out and new models have to be new models have to take its place. So this is the life cycle of a model at a very high level. As I said, this is AI models have a kind of domino effect. If you do something wrong, even at the design and development stage, uh, that impact would be there towards the end. Had it been a linear kind of models, you could have somehow managed it by changing the parameters, calibration, and so on and so forth. But for AI models, uh, it would be very hard to replicate such a strategy, and you may have to rework on the models from the scratch to get the necessary efficacy. So that's why we say that this has a kind of domino kind of effect. Now, some of the best practices at each and every stage, there are a lengthy list. I will just restrict myself to the important ones. So prior to the new development of a new model, thorough homework needs to be done. Whether you are going for an in-house model, third-party model, whether you are going to use in-house data, third-party data, whether you are going to calibrate models or develop new models, what is the technology platform that you are going to choose? And that technology decision has to keep into mind various other factors, such as what is the technical debt which you are already carrying, what is the technology lock-in that you are going to have for the next 5 years, 10 years, and so on and so forth. So all these factors have to be decided, in advance, and a buy-in from the engineering team must be done before the model is ruled out. And of course, the choice of model, there is always, considering the choice of model, there is always a trade-off between the sophistication of model and other factors such as data availability, model soundness, and so on and so forth. So you could have a very sophisticated model, but at the end of it, if the data is not available in a clean form, on a production data, by data I mean the production data, meaning the data which you are going to which the model is going to face in the production environment, it is not there, then there is no point actually. So there is always a trade-off, and you'll have to maintain that fine balance. And model development environment should be thoroughly sanitized and demarcated, so that any intentional or unintentional mix-up of data from other environments, let's say UAT environment, does not creep into the model. Had it been a linear model, again, as I said, you could have just managed it somehow. But AI models, let's say you retrain the data based on some junk data, the model gets retrained, you will have the results which were not intended. So the sanitization has to be very carefully maintained. And of course, as I said, prior to your production, you need to go through various levels of testing and authentication, including pilots, doing a limited release over a specified segment, customer segment, getting their feedback, stabilizing the models, and so on and so forth. So model, you don't launch a model on one fine day. It does not happen like that. You need to go through various phases, and those rigorous phases needs to be followed to you need to get feedback at each and every stage, and then probably fine tune the model, and then only it is slated for a model release. So during the deployment stage, again, as I said, this is a follow-up of whatever I said. A fine-grained role-based access needs to be maintained between production environment and other environment, because there have been umpteen cases where models were being used without proper authorization, and it has impacted the performance of the model. The model performance could be impacted through various means. So it could be wrong data getting mixed up with the training data, the slowness of model, and so on and so forth actually. So strict role-based access should be maintained between the production environment and other environment. And linkage to source systems, whether it is real-time or offline, this needs to be again carefully maintained. The data pipelines needs to be very carefully established. The important factor you need to consider is you should be able to trace back the data, where it has come from. That ability to trace back should be maintained. And periodically, what happens is that, let's say you are taking in data from a third-party data source. Suddenly, the data provider changes the dimensions or the specifications of the data or the data fields. So, I mean, you might never realize it, but that could have, come and hit your model actually. So, periodically, your source systems must be validated, and for validation of those source systems, data traceability is a must. You have to trace back, go to the data source, ensure that the data is coming properly and in the form and in the intended form, so that this does not have an implication on the performance of the model itself. And of course, there are various AI models which does real-time compute, where real or near real-time computation. This has to be carefully, I mean, how you kind of roll it out would depend on various factors, which we have already discussed. Let's say, for example, the network latency, the queuing, how do you queue and manage the data stream which is coming in. Then offline storage of data, where do you store the intermediate computation. And one important factors is that too many transformations on the fly should be avoided, because if you're not able to trace back what transformations have been done on the fly, then the question of traceability goes away, and again, we go back again to the problem of explainability of the models to various stakeholders such as auditors, etc., etc. So how do you maintain that balance, and what you store, what you don't store, is a very conscious call to be taken. Then at the usage stage, we need to be very careful of the, type 1, type 2 errors, because the true flags are not available. True flags are available only, after a lag of time. Let's say you are doing a fraud risk model, your transaction based fraud risk model, where you identify fraudulent transactions based on certain scenarios or certain use cases. There, the model can identify what is suspicious transaction. It can point out what is the degree of suspicion. So ultimately, whether it is a fraud or not will lie on the judgment of the user, the end user actually. So that takes place much later actually. So the flags are not immediately available, and hence one should be very wary of the type 1, type 2 errors that could creep into such models. Then data drift, we have already talked about this. Data drift could be caused by various factors, including customer preference, change of data, so on and so forth. Here, human oversight is a must, especially when it comes to the quality of data. So this has to be very carefully managed. Therefore, what can be done is a daily health check on various key parameters, including data, your results, as a dashboard or something, some of which I'll showcase it towards the end of this program, so that any abnormal function fluctuations in the output could be immediately noticed, and proper measures could be taken to kind of rectify that. So, if you were to consolidate everything, we can look at the model lifecycle management as 3 pillars, meaning the first pillar is the governance part of it. So governance would include the standards for model design. So you need to have proper standards for design and development. It is not that anyone can develop a model depending on their kind of approach. There needs to be a standardized process in place for both development and approval of models. Then change management, in the sense if a parameter needs to be changed or calibrated, or if the model itself needs to be changed, so how do you kind of authorize that change? So there needs to be a very well-defined process for that. Then there are other aspects of model materiality. You could be running 100 models actually. So which of the models are material? Which of the models are contributing to the revenue, directly contributing to the revenue, or which of the models are impacting my bottom line in terms of predicting the defaults and so on and so forth. So those are material models. So material models have to be identified, and they have to be very carefully managed. And again, it's a very vast topic by itself. Then model inventory and ownership. Inventory would mean an inventory of models based on their various stages in the life cycle. Some models could be in the development stage, some models could be in the usage stage. So how do you keep track of those models? So these are some of the important aspects of governance part. Then coming to the validation part, we need to have a validation calendar, again depending on model materiality. Models which are very material in nature, they have to undergo frequent validations, let's say in a month or in a quarter, or and these validations could be of different complexities. Some of the validations could be a health check, like on a daily basis you do a health check. Some of the validations could be very complex, very detailed, like you do a thorough analysis and so on and so forth. You give it to a third-party consultant to validate it and so on and so forth. But the bottom line is we need to have a model validation calendar where all the material models go through a specific validation exercise. And then, of course, once the validation is done, so how do you identify the issues, classify the issues, and it is sent for remediation. And whether those remediations are incorporated back into the models, again, those things have to be dealt with in a very specific, refined process. So that's on the model validation part. And lastly, the challenger models. Challenger models is a must, at least when it comes to the AI models, where you need to have another model running in parallel, which will kind of be a challenger to the champion model, which is the original model. So we need to look at both of them, monitor the results of the champion model and challenger model, and if there are any abnormal deviations over a period of time, then measures must be taken to address it. So running challenger models is one effective way of monitoring AI models, and we shouldn't assume that whatever is the model that we are running, they are the best, because model needs to be observed over a period of time. And for setting the benchmark for this observation exercise, challenger models are a very effective component. And of course, you need to take care to ensure that those challenger models are comparable in nature. So to summarize, as I've already told, deploying ML models are becoming a child's play these days. I mean, you don't need a data scientist to deploy an AI model. There are plugin models, n number of plugin models available in the market. All the major cloud providers provide it. You just have to plug into the platform, fine tune it to use case, and the model starts running. But that does not solve the problem. It's like it's like your baby or a child. You need to constantly keep monitoring it. Providing your attention to it. Ensure that nothing is wrong. Then ML models are not meant for solving problem once and forgetting about it. It doesn't happen that way. If it is done that way, ML models create more problems than what was envisaged. What was there before you had the ML models in place. Then when ML models stop performing, deciphering what went wrong is horribly tedious. You just cannot find what went wrong. Rather, the best thing is to do a proper lifecycle management, lifecycle management, to ensure that the deviation or the variation is spotted well in advance when you take remedial measure, rather than waiting till the end. So to conclude it, there is no substitute for rigorous model lifecycle management and model risk management framework. So that's a summary of whatever I was trying to convey. And each of it is a very big topic by itself. Let's say if you were to speak about model bias or model explainability or model risk management, it's an entire topic by itself, and we can cover probably an entire session based on that. So these are some of the references which you could use for further reading. Some of the interesting references that that would help you. Specifically, you could look at model risk management guidelines from Fed and ECB, and of course, European Union has come out with the EU AI Act recently. It was one of the very first regions to do so. Definitely, one should take a look at it. So that's all on the, on the sorry for the discussion part. Now, how it is done in real life cases. There are products available in the market which will help you to monitor the model life cycle. I mean, across models across the life cycle. For example, this is just an example of how do you set a validation plan or a validation calendar. So as you said, depending on the criticality of the models, you could fix a date, or let's say some of the models have to be done quarterly or monthly, whatever. And then you could have a validation plan around it so that you can keep track of the dates, and the team knows well in advance when the validation is going to happen. So planning a validation calendar happens like this. Then model inventory, where you have the entire list of models. See, models does not necessarily mean what is running on platforms such as R or Python or SAS. Even your Excel spreadsheet can have a VBA code which could churn out certain models. So even those have to be managed, and managing Excel models is the most difficult thing to do. So how do you keep track of it, and how do you distinguish it between the different model lifecycle stages? Who is the owner? Who is the developer? So all those things are kept track of through the model inventory. Then change management process, like how do you kind of manage the change, like in terms of how do you authorize the change, how do you approve the change? Because a developer may develop a model, but what if he were to come and modify certain aspects of the model without informing the business team or the other teams, the downstream teams about it? Actually, what is the implication? So model changes have to be authorized. And depending on the change, it goes all the way up to the senior most level. Then tracking the models performance through various statistical techniques. Again, the statistical techniques vary based on what kind of models you are looking at. Managing them against the thresholds. So you need to set thresholds in advance. So you need to set thresholds in advance, saying that I consider the results of models to be poor or marginal if it were to if it doesn't cross these thresholds, and so on and so forth. So how do you set the thresholds? So all these are policy level decisions to be taken at the highest level, and monitored, and the models have to be performance of the models have to be monitored very on a periodical basis, depending on the model materiality. So that's what it is all about. So there are a number of tools and platforms available which will help you to do that. And this is just an example of how visually you trace back the performance of the models using various statistical techniques. And lastly, you can have a kind of heat map or a compliance checklist where you trace the models for various compliance aspects, both including internal compliance as well as external compliance. For example, does it your right from the development stage? So has the model been built on true representative of data, which is a true representative of the population? Who authorized the model development? Who authorized it to the production stage? And all so such aspects can be kind of maintained as a checklist, and eventually it can be treated. Consolidated as a heat map as well. So depending on the model materiality, you look at the heat map and say what is working, what is not working, and eventually take steps to mitigate the issues. So that is what is required for AI model development. So in summary, as I said, models management has to be continuous basis, has to be done on a continuous basis. It is not a one-time effort, and it has to be carried out across the life cycle of a management, right from development stage, deployment stage, usage, and eventually you'll have to plan for the model's retirement as well. Yeah. So I'll stop with this. Any questions I would be happy to take.
Kasturi, would you like to take some questions quickly?
Sure, Sukriti.
Yeah, I've shared some with you. If you could just have a look and at least take the important ones, we'll just spare 5 minutes.
Sure. Sukriti, I'm not able to see the questions for some reason.
You can check the questions panel, Kasturi, in your control panel. Just check the questions window.
Yeah, I got it. Yeah. Yeah. Riza has asked, why would there be different versions of models for different locations? See, it would be so right. Let's say you are running let's say scoring model for a particular geography. Let's say the northern part of India. It is not necessary that the same demographics work with the eastern part. Because the demographics, the income levels could be very different actually. So you might work, and the availability of data also. So you could have a totally different model running for a different location altogether. Again, all these are kind of policy level decisions that needs to be taken. Do I do I run do I run one single model across the country, or do I maintain different versions of the model for different geographies? So it's a policy level decision that needs to be taken. It's a trade-off actually. If one of my business segments is kind of heavily concentrated in a particular geography, but not so concentrated in another geography, I might want to have another a specific model running for that geography alone, because for various reasons, for business reasons, my data, business reasons, I would want to serve the customers better. I would want to serve a larger segment of the geography, and so on and so forth. So for this reason, there could be different models running for different locations. It's a policy level decision. It's not a must, but it's people do that actually. I mean, there are companies which are doing that. And again, one more question from Altaf, which asks, will a centralized data governance model solve the issue around data issues? Yes. So data governance is generally centralized. You don't, unless you are a very large organization, you don't go for a decentralized data governance. You generally go for a centralized data governance process, because your policies are set at the central level, and it is easy to monitor them at a central level as well. So data governance is usually centralized only. See, data democratization is an altogether different aspect of, which is beyond the scope of this discussion, but it's a totally different aspect, Altaf. Then the next question is from how data is governed in AI models to suit for social media analysis. So again, here you have to take into account various aspects such as your personal data, what is appropriate for your data analysis, what the law permits. For example, some of the personal data from the social media, you can use it at a portfolio level, meaning you can use it at a consolidated level, but you can't use it at an individual level. So you need to be aware of all these nitty-gritties, particularly those surrounding the personal use of personal data, and then do the data governance part of it. That's one aspect of it. And second aspect of it, how much of your segment is covered by social media? I mean, if you are if you are targeting a very affluent customer, maybe a large proportion is covered by social media. But if you're targeting the not so affluent customers, then how much of your data you are getting from the social media data sources? And how critical is ultimately to you, to the business purpose that you are intending to? Like if you're doing a credit scoring based on social media, then does the social media give enough data? I mean, social media data for the customer segment that I am looking into, does it give enough data and weightage, and does it improve the model performance drastically, is what you should be aware. So it is not that you should use social media just because it is available. So what ultimately, what value does it add to my model, considering my particular case, that needs to be looked into. See, and there's one more question from Uttama Kumar, which says, can Slack model is best, or sandbox testing models is best? Justify it. See, again, there is no one testing process which you can call as the best. Actually, we need to look at it from the particular circumstances surrounding it. For example, sandbox testing. Sandbox testing is you use when you use certain very confidential information. For example, when you're using a bank's data or some kind of data, credit bureau data, which is very confidential information, you generally use a sandbox kind of testing process actually. But there are other testing processes, such as, for example, pilot testing. So when you feel that the model is ready, I mean, instead of launching it immediately, you need to do a pilot for certain segments of the society, for your customer segments, get the feedback, and then do the model refinements, and eventually launch it actually. So there are various testing approaches, and what is the right approach? You need to approach it depending on the particular circumstance. Do we have more time, Sukriti?
No, I think we've already spared more than 5-7 minutes here, Kasturi. Probably our audience can get in touch with you through LinkedIn and get their queries sorted, more or less. For those of you who are asking for the presentation, we'll not be sharing the presentation, but the session has been recorded and be available in 24 hours on the same webinar page. So in case if you've missed anything, any recommendations that Kasturi has shared, the the model, the chart, the fundamentals, all of it can be accessed in 24 hours. You can just have a relook at the entire recording, and you should be good to go. Kasturi, thank you so much for taking your time out for conducting this wonderful session with us.
Thank you, Sukriti. Thank you all for patiently listening to me. Please do feel free to reach me out on LinkedIn. I'll be more than happy to connect and address your queries.
Wonderful. So folks, I'll be back with another webinar very soon. Till then, stay safe, take care, and please ensure that you get back to the webinar in case if you've missed anything. Thank you so much once again. Thanks, Kasturi.
Thank you, Sukriti. Thanks.